Okay, so today on the bench we have a kind of an oddball radio, if you're watching this video in the United States, because this is a Euro CB. So yeah, this is mainly the only place you'd ever see these would be in the Euro countries. This is a model Pacific 4, or actually Roman numeral 4. It's an AM, FM, and sideband radio, and actually has indicator lights for sideband modes, FM and AM. Now this radio when it left the factory, it was a 40-channel radio, but it was, I guess you could say, intentionally designed to be an 80-channel radio. So this is kind of a poor man's clone. Let me just turn it off here and get the microphone adapter off of it. It's basically a poor man's President Jackson, I guess you could say. The circuit board is similar. Yes, it has a little, it has their weird little box hanging off the back end of it there. But like I say, it's basically like a poor man's President Jackson. Now, the President Jackson used a pair of binary adders. Because if you've ever seen a President Jackson, it's a multi-band radio. And that's what those binary adders are used for, is to be able to get all those channels with just one channel selector switch. They don't do that in one of these. What they use is an EEPROM. So there's another little board down here with an EEPROM on it. Okay, but from the factory, it doesn't really do much. So the way it's set up, normally this wire would not be attached to it. That wire would have been, well, actually kind of like this wire, just sticking in the radio, not doing anything. And the modification is you unplug that wire, and that's actually for the ANL. So you unplug that wire, and you put this wire onto this board. And then that enables the high channels. So when you push in the ANL button now, you get 40 upper channels. But customer sent this in to have it looked over, have an alignment done, anything it needed done. And of course, the first problem I run into there is, if you look onto the great interweb and try to find any information on one of these things, good luck. There ain't none. There's no service manual. There's no schematic. There's pretty much nothing. It's just the silence, the deafening silence of crickets when it comes to trying to find service information. So, of course, trying to do a transceiver alignment without any information can be a little bit of a challenge. Now, if you work on radios for a living, 90+% of this, you can just look at it and go, yeah, receiver, 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 transmit, transmit, okay, the location of that one, that's probably that's almost always going to be the one beside the mirror board here is always going to be your RF power meter. That's going to be probably your signal meter. And you can figure it out, your ALC, AMC adjustments, FM deviation, your transmit frequency adjustment pot down there, squelch control and stuff like that. But when it comes to actually doing the frequency alignment, yeah, that's a little bit more difficult. You can't just kind of look at it and go, yep, okay, I should get this frequency at that point in this mode on this channel. You need a little bit more information to do that. And unfortunately, like I say, there is none on this. Now, like I say, this radio is very similar in design to the President Jackson. It uses the same style, or not style, but it uses the same frequency, 10.6975 crystal here. So those frequencies are going to be the same, and I'll actually show you. I've got a little cheat sheet for you to show you for these adjustments. The big kicker is this crystal down here is a 14.160 megahertz crystal. Now in a President Jackson, that's actually a 14.55 megahertz. So yeah, the frequencies are going to be different. They're not going to be the same. And also this radio has absolutely no test points. I mean, there's probably test points there, and it's just nothing is labeled. Usually in most, unit and chassis radios, if they're going to use, let's say, a resistor as a test point, all the resistors that stand up proud off the board and have the leads bent over, well, if they use them as a test point, they will not have painted leads, where all of these do. Yeah, it's not like that. They just kind of, so you're left just kind of looking in the radio going, yeah, somewhere in there is a test point. Where? So I had to reverse engineer basically all of that to figure out where all the test points are. So get out your pen and paper, pause the video. You'll probably never see this. Get the radio out of the way. This is, if you're a tech, this is all you need right here. If you're not a tech, well, this isn't going to do you any good. But there's all the information you need to do a full alignment on this radio. So, your normal receive chain, that's pretty much the same in most any radios, actually any CB, most CB and even export radios. Your receive chain's usually kind of in a U right here. Your FM adjustment, transmit adjustments. There's your PLL chip, and I did indicate where the crystals are. So the 10240, the 106975, and the 14.160. Now, as far as test points go, you'll see that I wrote down VCO TP and a little dot right there. So if you actually look in the radio, let me get a pointy thing because my finger is way too big. Now this is a double-sided board. You can see there's circuit traces on top of this, and it actually has through-plated holes. So this is kind of an improvement over the earlier double-sided boards used in CBs, because those back then did not have through-plated holes. They just had traces on either side, and they connected the traces from top to bottom with a piece of wire. This actually does have through-plated holes, but the point you're going to want to test is right there. That little silver dot, that's actually a pass-through. So if you hook up your frequency counter to that point right there, that is that point right there, and you're going to be adjusting. I'll move my paper up here. These three transformers are actually, they're tunable coils, but right here, and I have the modes written below it, AM, lower sideband, and upper sideband, and this is what you're going to do. So put the radio on channel 20, clarifier centered, and adjust for these frequencies measured at the VCO TP right there. So in AM, you're going to want 16.510, lower 16.5075, upper sideband 16.5125. Your 16.975 adjustment, actually that's the first one you would do. You do this adjustment first, then you do these adjustments, and then you do the last thing you would do would be put it in AM and adjust this one for your transmit frequency. But your 10.6975 adjustments are these three cans, so upper sideband, lower sideband, AM, and I just wrote the frequencies below them because they don't change with the channels. They always oscillate at that frequency. But 10.695 for AM, 10.6975 for lower sideband, 10.6925 for upper sideband. And yes, that is correct. The lower sideband frequency is higher than the upper sideband. Some radios are like that. Not going to get into why. This video is just to show the test points. And where you want to measure that is capacitor C95. It's back behind on the right-hand side of this crystal. It's just a ceramic disc capacitor. You're going to want to test on the rear leg of that. So I wrote down 1069 TP. So that capacitor is that one right there. Actually, I put a little red dot on it even. Well, it shows up in the camera. On the back side there has a little red dot. So when you're looking down at the radio, you'll have the crystal. You come back, there's one ceramic disc capacitor here. It's the one behind that. So right there. Hook your frequency counter up to the rear lead of that one, and that's where you get these three adjustments at. Other than that, pretty much, like I say, straightforward, the normal trimmer pots. You're going to have your driver and final bias controls. They have them marked as pin 1, 2, and 3 for your mirror board, and the mirror board's soldered in these. I hate that. You have to unsolder it to get it out for your bias current. Your RF power meter, ALC, AMC, AM/FM power, your S meter, like I say, transmit frequency adjustment, your squelch control, and FM deviation. Now there's one thing, and then this transformer right here, that's your VCO voltage adjustment, which was fine in this. That's why, if you notice, the wax hasn't been tampered with, because I didn't need to adjust that. The frequencies were horribly off. Someone had tinkered with that and made it. Actually, I had a heck of a time figuring these frequencies out right here, because I actually had a heck of a time figuring these transformers out, because someone had these adjusted so far out in the opposite direction that the upper sideband was transmitting on lower sideband, and the lower sideband was actually showing up in the upper sideband. Yeah, but I couldn't get the upper sideband up far enough, and it finally dawned on me that's because they had them tuned in the wrong direction. But so neither here nor there. And then T13 here, that's your buffered VCO output. So what you do normally when you're doing your alignment before you even adjust these frequencies, what they'll tell you to do is attach an oscilloscope probe here, on your center channel, and adjust T13 for maximum RF power measured there, and then you would attach your frequency counter and you do these 3 adjustments. But like I say, there's pretty much the scheme of things. So like I say, you can pause the video, write all that down, or just freeze it and print, or pause the video and take a snapshot of your page and print it out. But there it is. That's really all you need for the alignment. It's pretty much like any other export radio. Or even American CVs, a lot of them, they're pretty much same design. They've all everybody's just copies of copies of copies. So that's pretty much it. Now there is one thing you may have noticed, and it's something that I noticed during the alignment. Didn't dawn on me when I was originally scribbling all this stuff down as I came up with the alignment points and measurements for this thing. What's missing on this page? Remember, this has lower and upper sideband. It's a sideband radio. What did I not mention? There's no carrier adjustment on this. Where's your carrier balance or carrier suppression? It's not in here. I have looked. It's not tiny, it's not standing up, it's also not on the bottom of the board. For some strange reason, they designed this radio, there is absolutely no adjustment for sideband carrier suppression. Yeah, that's kind of where I'm left at. I've never seen, I don't think I've ever seen one. Did they forget to design that into the radio? Yeah, if you have a horrible carrier spur, you're going to have to do some I'm sure they just probably used a fixed resistor value, but that should have been an adjustable circuit. So if you've got a big carrier on sideband, you're going to actually have to do some troubleshooting and change a value. So, but that's luckily this one was, But there you go, and there's the back of the radio. Nothing fancy back here. Like I say, just the ID label, made in Korea, PA external jack, your power supply, and then this nifty little box that they have the antenna connector on. I did not take that off. I'm assuming all they have in there is probably a little bit of extra, probably just a choke or maybe an extra, like a double 54 megahertz trap circuit, because you've got your trap circuit over here, but they might have stuck, there's actually a circuit board in there. I'm looking through the hole there. So if I had to take a guess, probably in that little box is probably an extra, they might have stuck a little bit of extra filtering in there. This is probably what that's for. But there you go. The only thing I need to do to this now is remove the glue. The alignment's been done, radio works good, and not much else to it. So, there you go. If you ever run into one of these, write that down. I'll just not touch the camera and leave that kind of flopping around. Lay it back on the table, copy all that good stuff down, and there's all your alignment points and everything you need to know. So I hope that helps somebody out, because, like I say, I looked online, just the deafening silence of crickets there. You find a couple posts, maybe people asking about, hey, does anybody have a service manual? And yeah, no replies. It does look like it's probably, actually, if you have a Euro CB model clear tone, I believe, don't have one in front of me, so I can't say for sure. And there is a schematic for that radio online, but it is so horribly, the picture is just, it's unreadable, basically. The schematic is just fuzz. Try and look at what I have written here through a piece of frosted glass, yeah, that's about what that schematic image that's online looks like. But from what I can see on that schematic, what I could barely make out, it looks like it's probably the same chassis. It looks like, I think it says 14.160 megahertz for the VCO crystal. So I get the feeling that this right here would probably be the same on the Euro CB clear tone. So anybody that has a clear tone, it's possible all of these adjustment points to include all of these frequencies that you'd be adjusting are going to be probably the same in a Euro CB model clear tone radio. So, oh, microphone jack, one last thing. If you have one of these, it is four-pin wired Midland style. So Cybernet, basically. It's wired like a Cybernet. Midlands, GEs, you know, anything like that. That's the wiring. That's actually one other thing I have to do. I need to change the mic wiring on this to 4-pin Cobra for the customer. But to do that, all you have to do is reverse. If you ever get a radio that has 4-pin Midland, like I say, most Cybernet chassis use that. All you have to do is reverse the wires on, and if there's any capacitors as well, which there are none, or no, actually there is one ceramic cap on this. So always make sure you always swap the caps too if they're on there. But just swap the wires on pins 1 and 2 with each other. You know, so take the wire off of 1, put it on the 2. The wire that was on 2 goes to pin 1. Same thing with pin 3 and 4. You're going to take the wire off pin 4, move it to pin 3. Whatever was on pin 3 gets moved to pin 4. That's all you need to do to change from Cobra to Midland style, or vice versa. If you want to go from Midland style to Cobra, just swap the wiring and components from pin 1 and 2 and pin 3 and 4. So there you go. Hope that helps somebody out. And if you own one of these things, there's basically all the information you need. So hope that helps.